Okay, we're ready to introduce our last section, 410, dealing with translations and parallel lines. You should know all about translations already, translations, in terms of how they're a slide. You learn those in geometry. Now we're just going to use them with matrices. And you should also have an idea about our parallel lines from geometry. So there'll be a little new information plus a little carryover. You can see we want to be able to recognize images and how they're related, so characteristics, relate those translations to matrices, which we've been doing all chapter, and then be able to graph the different shapes of the figures. So to get started, let's think of our new, because you've read, our new notation for a translation is H or T sub H comma K. It looks a lot like, if you remember, our scale change that had A comma B. So there's two subscripts down there, there's two subscripts on ours. But this HK is the same HK we saw in our point slope equation. This H will stand for, think of sliding the figure H units to the right, horizontally or left, and K units vertically, up or down. So H is for the horizontal, K is for the vertical. This movement would add or subtract values from each other. What does that mean? So let's start with our brown rectangle sitting right here at the origin. And if I said, go ahead and take that brown rectangle and move it 5 units to the right, you're thinking, well, wait a minute. So it would go something like, take that same rectangle and move it 5 units to the right. I would go 1, 2, 3, 4, 5. And that would be my final position for this new rectangle. What did I do in terms of a translation? You should be thinking, well, she just did a translation of 5 units to the right and 0 up. If I would say do the same thing and do 3 to the right and 2 up, so again, start where we're at. 3 to the right, you could go 1, 2, 3, and then 2 up would put us at 1, 2, would leave us sitting right here. It almost looks like it moved diagonally on the screen rather than just right, left, up, or down. So in that case, the yellow one would be a translation, whoops, didn't mean to move ya. It would have been a translation of T sub 3, comma 2. Now remember, the H value and the K value. The H moves you left or right. The K value moves you up or down. Those are your only choices. So if you have an H and a K value, it appears like this one that we're moving on a diagonal. It's just because you're using two motions. All right, with that, let's move on. That means, well, what 2 by 2 matrix represents a translation? Because we've had this whole list. We've got 9 of them sitting there. And what you got to remember is we're looking for that 2 by 2. But what I did to that original matrix wasn't multiplication. You just heard me as I moved through some things on that last slide. So let's go back. What was I doing when I moved from the brown one to the blue one? What was I doing when I moved from the brown one to the yellow one? I wasn't multiplying anything. I was counting. 1, 2, 3, 4, 5 to get to the blue. 1, 2, 3, up 2. I was just moving, counting. So there is no multiplication going on here. And because there is no multiplication, that means there cannot be a 2 by 2 matrix that we would use. Okay? There would not be a 2 by 2 matrix. So we can say we have the translation of H units horizontally, K units vertically. We would add to get our shortcut. Okay, that's what you're seeing here. All right. from here, we need to make sure we add to our chart table that has our 10 matrix combinations on them. And the name is a translation of H units horizontally. You don't want to just say translation because it's very specific. The notation is T sub H comma K. There is no 2 by 2 matrix because we are not multiplying, which is what every other transformation used. And now we want to say our shortcut has actually left part of that out. Our shortcut is whatever x, y started as, the outcome is x plus h and y plus k. So you get a new ordered pair where you're adding the h, k value. So now your list should be complete. You should have 10 of them on them, and this is the only one that does not use matrix multiplication. So last but not least, it says, what translation maps BEST onto B prime, E prime, S prime, T prime? So I'm basically saying, here's my points, point B, E, S, and T, and they've now become B prime, E prime, S prime, T prime, and by looking at them, you should be able to tell me the translation I used. So we know the X values all got an H value added, and we know the Y values all got a K. So it's your arithmetic that's going to be involved in your thinking here. So I'm saying, okay, if I look at my X's, 0 plus what equals 2? Well, that one's not hard. If I say 2, and then I need to check, is 6 plus 2 8? Is 7 plus 2 9? Is 2 plus 4? So you need to make sure it works for all of them. So right now we've found out that our translation for the X value is a 2. So we can go T sub 2 comma, and now do the same thing for the Y's. 6 plus what gave me a 5? Well, 6 plus, in this case, it'd have to be a negative 1. Check the other ones. Is 7 plus negative 1? Is negative 2 plus negative 1? And is 2 plus negative 1? 1. So if they all work out, then you're good. If something's wrong, you want to go back and check your arithmetic. So the Y value should have been a negative 1. So we had a translation of 2, negative 1 here. It would move 2 to the right and then down 1 if we would actually graph it. But it saves you time because you just look at the values. Now it says translate BEST through a translation of T sub negative 2, 4. So you're thinking, okay, BEST, which is your original, okay, has to go down 2 for each x. So if I'm at 0, down 2. If I'm at 6, down 2. If I'm at 7, down 2. And if I'm at 2, down 2. And lastly, the y's, up 4. So I said down 2. We were actually moving left 2. Now for the y's, we're moving up 4. So 6 plus 4 would give me a 10. 7 plus 4 is 11. Negative 2 plus 4 is 2. And 2 plus 4 is 6. So our new matrix would be negative 210, 411, 52, 06. Could you graph those? Absolutely. Could you move things on a graph just like we did earlier? So if you have any issues with that or questions about that, please bring that to class with you. That's all for today.